Hello friends, in previous lecture we discussed the reactions of alcohol in which reaction involving cleavage of oxygen hydrogen bond and the reactivity order follows the primary alcohol, then secondary alcohol and the tertiary alcohol. After that, reaction involving cleavage of carbon oxygen bond in which we focus on the Lucas test or the Lucas test. It is nothing but the alcohol plus ZnCl2 and HCl. To classify the primary, secondary and tertiary alcohol, we use the Lucas test. Now the esterification, we know the esterification, that means the addition of acid plus alcohol, we get the ester. Then oxidation, that means the loss of electrons. Various types of oxidizing agent, that is potassium dichromate, alkaline KMnO4 or dilute nitric acid. Primary alcohol, it undergoes oxidation, we get the aldehyde. Then secondary alcohol, it undergoes oxidation, we get the ketone. And in case of tertiary alcohol, these are generally resistant to oxidation in neutral or alkaline solution, but under acidic condition, the tertiary alcohol, it undergoes oxidation to get the ketone, and ketone, it again further oxidation, we get the acid. Now the next oxidizing agent is PCC, that means pyridinium chlorochromate. It is the best oxidizing agent to stop the reaction at aldehyde and ketone stage. After that, opener oxidation. Opener oxidation, it is nothing but the secondary alcohols on reaction with aluminum tri-tertiary butoxide in presence of excess of acetone, we get the ketone. Then diol, oxidation of the diol by using the periodic ester. Then KMnO4 and pinacol-pinacolan rearrangement. Pinacol-pinacolan rearrangement, it is the take place in acidic condition and it is related to the migratory aptitude. Then uses of alcohol, that part discussed in previous lecture. In this way we completed the alcohol. Today we will start the remaining part of alcohol, phenols, ethers, in which we focus on the phenols. That means in alcohol, phenols and ether, we start the phenol. First, introduction of phenols. Then first, phenols, definitions of the phenols. The aromatic hydroxyl compound in which one or more hydroxyl groups are directly attached to the aromatic nucleus, that is benzene ring, are called as phenol. That means the benzene ring containing one hydroxyl groups, such a compound is called as the phenol. And they have general formula AROH. We can represent the phenol by using simple formula AROH, whereas AR is phenyl or the substituted phenyl or some other aryl groups, example naphthyl. So how will you define the phenol? The aromatic hydroxyl compound in which one or more hydroxyl groups are directly attached to the benzene ring are called as phenol. Here C6H5H, here this is the benzene. If we replace one of the hydrogen of the benzene by OH, and here we get the C6H5OH, it is nothing but the phenol. Now then example, here are some example. This is the phenol. Now then O cresol, that means hydroxyl group, and here CH3, M cresol OH and CH3, P cresol OH and CH3. The positions are different here. Now then 2,3-dimethyl phenol. These are some examples of the phenols. Next, classifications of the phenols. Phenols are classified into three types. Number one, monohydric phenol, that means containing only one hydroxyl groups. Dihydric phenol, that means two hydroxyl groups. and trihedric phenols, that means 3 hydroxyl groups. Now the monohydric phenols, here example, monohydric phenols, that means only one hydroxyl groups. Here the aromatic ring, the benzene ring containing only one hydroxyl group, therefore name of this compound, it is the phenol. It is the monohydric phenol, or it is also called as the carbolic acid. Second example, here we have to remember that the numbering is always starting from this hydroxyl. This is 1. That means the 2 aromatic ring or 2 benzene ring containing only one hydroxyl groups. Therefore, this is an example of the monohydric phenol, and name of this compound is the alpha naphthol. It is also called as the 1-naphthol. Now then here hydroxyl group containing one substituent. Here number 1 and 2. And here name of this compound is O-cresol. O-cresol or the ortho-cresol, because they are 1-2 position. Therefore O-cresol, or the name of this compound 2-methyl phenol. Another example of the monohydric phenol, here 1, 2, 3, and name of this compound is M-cresol. That means meta-cresol, because they are 1-3 position to each other. Therefore meta-cresol, name of this compound 3-methyl phenol. One more example, here 1, 2, 3, 4. Okay, it is called as the P-cresol, because they are para to each other, 1-4 relationship. That means the para. Therefore P-cresol, name of this compound is 4-methyl phenol. Then if the phenol containing one more substituent, that other functional groups, aldehyde, at that time numbering starting from this aldehyde 1, 2, 3, 4. Name of this compound 4-hydroxybenzaldehyde. Suppose acid is present, C double bond OH, carboxylic acid, then it give first number, then hydroxyl groups 1, 2, the name 2-hydroxybenzoic acid. One more ester group, then always it gives first number 1, 2, 3, 4, and name of this compound is 4-hydroxyethyl benzoate. These are the examples of the monohydric phenol. Now the next, dihydric phenol. Dihydric phenol, that means benzene containing the 2 hydroxyl groups. Here 1 and 2, that means catechol. 1 and 2, that means the name of this compound is catechol, or it is the benzene 1,2-diol. One more example, benzene containing 2 hydroxyl groups. Here the position is 1,3 position. They are the meta to each other, and name of this compound is resorcinol, or benzene 1,3-diol. Another example, here 1, 2, 3, 4. These 2 hydroxyl groups are para to each other. Hence the name of the compound is hydroquinone or quinol. Compound having name benzene 1,4-diol. Next, trihedric phenol, that means the benzene containing 3 hydroxyl groups. Here numbering 1, 2, 3, 4, 5, 6. That means fluoroglucinol. Fluoroglucinol. Okay, this is the actual name, and name of this compound here benzene 1,3,5, because 1,3,5 here the position of this hydroxyl group, 3 hydroxyl group, therefore benzene 1,3,5-triol. One more example, if the benzene containing 3 hydroxyl groups, at that time the numbering from this 1, 2, 3. Okay, and pyrogalol, benzene 1, 2, 3 triol. When benzene containing 3 OH group or hydroxyl group, at that time the numbering starting from this one, and all are include, not from this direction, from this direction, that means 1, 2, 3. Now next example here, these two OH are close and these are away, that means they are different positions. Now then at that time here 1 2 3 4, okay, because all three OH groups are come from this direction, 1 2 3. Therefore name of this compound is benzene 1,2,4 triol. Benzene 1,2,4 triol. Now the nomenclature of phenol. The phenols are generally named as a derivative of simplest member of the family that is phenol. The methyl phenols are given the special name that is cresol, or sometimes phenols are named as the hydroxy compound. And there are two ways for the nomenclature. Number one, by numbering of the carbon atom of the ring attached to the hydroxyl groups, always numbered as 1, and the remaining carbon atoms of the ring are then numbered as 2, 3, 4, 5, 6 in clockwise or anti-clockwise manner depending on the substitution pattern. That means the benzene containing hydroxyl groups, at that time the numbering is always starting from these hydroxyl groups, that means it gives the one number, and remaining carbon atoms in the ring are numbered as 2, 3, 4, 5, 6, whether it is clockwise or anti-clockwise manner, it depending on the whatever substitution is present or substitution pattern is present. That means benzene containing hydroxyl groups, it always gives one number, then goes remaining carbon 2, 3, 4, 5, 6 in clockwise or anti-clockwise manner, and depending on the substitution pattern. This is first way. Now the second way, as ortho, meta, para derivative of phenol. We know the ortho position, meta position and para position. By using this we can give the name to the phenol. Then here this is the structure of phenol, and here numbering are given 1 2 3 4 5 6. Here this is 1 2 position with respect to this hydroxyl groups. Here this is ortho, that means 1 2 position it is ortho. Now then with respect to these hydroxyl groups, they are 1 3 relationship, that means the meta, and this is 4 number position is para with respect to this hydroxyl groups, 1 4 position, that means the para. Now then name of this compound is orthobromophenol. Why this is ortho? Because with respect to this hydroxyl they are a 1 2 relationship, therefore orthobromophenol. Name of the compound is 2-bromophenol. That means second, here 1 2 3 they are 1 3 relationship. Here not ortho, here actually meta nitrophenol. It is also called as the 3-nitrophenol. Now the next, here 1 2 3 4, here they are 1 4 relationship, that means para chlorophenol or the 4 chlorophenols. Here numbering starting from this hydroxyl, here 1 2 3 4 5 6, that means 2 4 6, it indicates the position of bromine, 2 4 6 3 bromine, therefore tribromophenol. And next here 2 4 dimethyl phenol. How this 2 4 dimethyl? Actually this is 1 2 3 4 5 6, that means 2 and here 4, okay, 2 4 2 methyl, therefore dimethyl phenol. And last example, hydroxyl group and NO2 group. Here therefore numbering starting from this hydroxyl, here 1 2 3 4 5 6, that means 2 4 6 trinitro, 3 nitro, therefore trinitrophenol, or it is also called as the picric acid. In this way you can giving the nomenclature of the phenols, or the simply for nomenclature of phenol, benzene containing hydroxyl groups, that it always gives the one number, and remaining carbon gives number 2, 3, 4, 5, 6, whether it is clockwise or the anti-clockwise depending on the substitution pattern. And second thing is that we can use the ortho, meta, para prefix. Okay, thank you.